Alright, so let's keep going now. I'm going to do multiplying two things together. So here I'm going to give you, let's say we have the square root of 10 times the square root of 2. I can't take the square root of 10. It doesn't break up into anything I can take the square root of. I can't take the square root of 2. Now from before, you know that we could combine these together and call this the square root of 20. And now can we break 20 up into something where you could take the square root of it? And you can. The square root of 20 is the same as the square root of 4 times the square root of 5. Right? Because 4 times 5 is 20. And why would I do that? Because you can take the square root of 4. Square root of 4 is 2. Square root of 5, I don't know. So when multiplying, we can multiply, get a number, and then break it up and find the square roots. But this becomes kind of tedious if you're multiplying lots of things. Why don't we just think a step ahead here and see if we can figure out that there'll be a 2 that comes out and a 5 behind. So this 10 here, I'm going to break this up and kind of just factor it. Isn't 10 the same as 2 times 5? And then I'm multiplying that by another square root of 2. So I'm back where I started. Instead of multiplying and making it 20, I'm just going to break the 10 up into 2 and 5. And then I'm going to look and see what I got here. We know that when we multiply these, it's basically the same as putting all of these under the same square root. And if you look, is there a pair of numbers that are under the square root? Are there like two things that would come out if they were in the same square root? Yeah, there's a 2 here and a 2 here. Well, we know in the next step they're going to be together, so why not just take that step out? I see a 2 and a 2 and a square root. Why don't I take those and put them in the front? Right? 2 and a 2 will escape the square root, come out in the front. What's left over? Just the 5 that's on the inside. Exactly the same as what we got up here. We just saved ourselves some step by breaking up the number first. Let's see how we can do this with other ones. If we could break them up first and then start pulling stuff out. So let's say here, what if I got the square root of 15 times the square root of 10? I can multiply these together, get a square root of 150 and then break 150 apart, but let's save ourselves some steps. Let's break this up and let's just break this up. The square root of 15, that's a 3 times a 5. Square root of 10 is a 2 and a 5. Now look, I know that both of these are going to go together. They're multiplying each other, so we could just say they're all under the same square root. Is there some number that there's a pair of, something that I could take 2 out of? Yeah, the 5s. So the 5s will come out to the front. There'll be a 3 and a 2 left over. Can you do anything with the 3 and the 2? No, you can't break up a 2 or a 3 or factor them at all, so they're stuck inside the square root symbol. Oops. So the 5 came out, and I'm left over with the 3 times 2 and the square root symbol. And we'll just simplify that. So we get 5 square root of 6. So the square root of 15 times the square root of 10 is the same as 5 times the square root of 6. Because each one of these here had a 5 in it that we could take out to the front. And then there was a 2 and a 3 left over, which made the 6. We can even do this with, I guess I'll do 2 more. Let's do square root of 20 times the square root of 12. I don't want to multiply these and get 240 and try to factor that. Instead, let's break this up. And let's be smart about how we break this up. Like, I don't want to list all the factors of 20. Like I think, what do 20 and 12 have in common? What do they have as a common factor? They both have 4. Right? Because 20 is 4 times 5. 12 is 4 times 3. So look, they both have a 4, which means I can pull out that 4, pull out that 4. There'd be 4 in the front. What's left over? 5 and the 3. Can we do anything with 5 and 3? You can't break them up. You can't take the square root, so they're stuck in there. I'll simplify by just multiplying like it says. So I get 4, and then there's a square root of 15. So square root of 20 times the square root of 12 is the same as 4 times the square root of 15. We broke up the 20. We broke up the 12, and then we saw that they both have a 4. Well, 2 4s will come out as just the 1 4. Do one more and just see what happens when there's exponents. What if, or sorry, exponents. Let's see what happens if there's variables. So we'll do it over here. It was square root of 10xy times the square root of 5x. And again, I don't want to go through all the work of multiplying this, taking square roots. Let's just think about this in our heads. This one, I'll break this up a little bit. A 10 is a 5 and a 2 and an x and a y. And then this is still, there's nothing we can do with a 5 and an x. And we look, what do they have the same? We're multiplying, so these are all going to end up together under one square root symbol. So let's save ourselves, not write all that. See, they both have a 5. So the 5s will come out. This pair will come out as just a single 5. They also have an x. Well, a pair of x's will come out of a square root as just a single x. And what's left over? There's a 2. There's nothing else. There's no other pair of 2 to go with it, so the 2's got to stay. There's y is stuck in there. There's nothing else for him. So that's it. We're done. The square root of 10xy times the square root of 5x is 5x times the square root of 2y. Because this had a 5, this had a 5, so they came out together as 1. They both had an x, so that pair of x's comes out of the square roots as 1. And there was just a 2 and a y left over, so they're hanging out. And that's how you simplify and multiply fractions.